Hi everybody, hope you're all doing good. I'm Apurva Anumalla. Today, I, along with my teammates Vamshi Reddy, Suhan Yang and Rajini Kumari, are going to present you our work on the project Optical Character Recognition using PyTesseract and OpenCV. Digitalization of records has come to existence in the early 21st century, prior to which there were only printed or handwritten receipts. For our project, we were provided with a dataset of images which were the scanned copies of forms collected from the burial records. Our project deals with moving to digital cemetery management system where we need a solution to transform burial records from scanned paper-based records to digital format. The main goals of our project are: number one, to identify the different types of forms. With the change in time, there were changes made in the form types and there were a mixture of both printed and handwritten ones. Number two, once the form type is identified, we need to extract the required information from scanned images with good accuracy. Let us look into our dataset. Of all the forms that we have, they can be categorized into 5 types. Type B1. It has a separate column for block. As we see, there is a separate column, a field for the block. Type B2. The block column is missing. The rest is similar. Type B3, where there are only horizontal lines and the vertical lines are missing. Type B4, which is similar to type B3, but there are no horizontal or vertical lines. Type B5, which is containing handwritten forms. To classify the form types, we have used a classification model and implemented it with the CNN classification model. Of the 200 images, we fed the model with 80% of the data for training purpose. The model successfully classified the images with the accuracy of 81.33%. Here we see the screenshot of the output of accuracy that we gained from the CNN model. Let us now look into the workflow. We have worked with 3 types of images, that is, type B2, type B3 and type B4. To begin with, type B2 has got horizontal as well as vertical lines, and type B3 has horizontal lines only. We have written a code to identify the positions of the lines. Also, since the data we require is concentrated in the upper half, we have cropped the image as required. The form B4 does not have horizontal or vertical lines. We had to find another solution. Here is a solution. We summed each row in the image and found range of indexes where there is high number of black pixels, which mean that the range contains characters. There were 4 rows of data in the image. In the 0:250 cropped image, that is the upper half of the image, we looked for 4 ranges in some of the rows. We further cropped each image from the obtained ranges using first and last index of the range. Now here is a text extraction. The below code is used to extract text from the given cropped image based on the coordinates obtained of the lines. Of the entire image, we are interested to extract the name of the deceased, the date of interment, and the section, lot, and grave number. Our output looks something like this. We also included a column that mentions which type of form it belongs to. Time column indicates the time at which the image is processed. For the data storage purpose, we used SQLite 3 in-file memory database from Django framework. We used Django models to structure our tables, and our table structure is ID, name, date, section, lot, grave, form type, time, image name. The name is the name of the deceased. Date is the date when he was buried. The section, lot, grave belong to the graveyard. The form type is the type of the form from our dataset. The time indicates the time at which the image was processed, and the image name has the image details. We conclude by discussing the pros and cons of our project. Let us discuss the pros. Without directly specifying field position for every image, our approach finds position of a field using custom algorithm. With this approach, we find exact field data in the image and submit it to Tesseract. Another advantage is that we can use the same image to Amazon AWS. We tuned PyTesseract to find only specified characters from a specific image. We were successful in extracting the text for most of the images. Now the cons. We did not perform denoising before text extraction. The model fails for some images which have black spots or irregular structures in an image. Because of the lines in the image, PyTesseract takes them as symbols. When an image is cropped with respect to the line also contains part of character which is important for the value. Thank you.